So what was this originally? Before it was factored, this was actually x squared minus 4x minus 5, right? And so someone said, hey, factor this, but really this is an equation, and so it was set equal to y. It was really y equals that, because if we say that y equals this, we can graph it. If we say y equals this, we can graph it. Pick your head up, please, and thank you. So we factored it, and we replaced the y with a 0. And I want to ask you something really fast. So I'm just going to draw a graph really fast. And if I ask you to factor or to graph y equals 2x plus 4, what would you do? How would you graph that? Linear. Take your brain back to like first unit, linear stuff. How would you graph that? Macy. Why would you start at 4? So that's the y-intercept. That's where you begin. So this is the ordered pair 0, 4. That means that I know that I cross the y-axis when x equals 4, correct? Okay. When do I cross the x-axis? Just think about that. When do I cross the x-axis? Meaning, what is how do you find the x-intercept? So I'm going to remind you of something like this. You don't have to even write this down. I'm just kind of remembering your brain on some things that you learned. Do you guys remember learning the cover-up method? This was how we graphed these with intercepts. This is standard form, okay? And we said, hey, if we cover up the 4y, we actually have the equation 2x equals 4, which means x equals 2, meaning that this equation right here is going to cross the x-axis at 2. And if we cover up the x, we have the equation 4y equals 4, which means that this graph right here is going to cross the y-axis at 1. Do you guys remember doing that? Okay, so this is where it crosses the x-axis. It crosses the x-axis when y equals 0. So in order for us to solve a quadratic, we have to let y equal 0. I know that's a whole bunch of stuff. We're going to get into it more, but I just want you to know where your brain is going. Your brain is going to the fact that we're going to start graphing these. We're going to start graphing these quadratics. So I have this quadratic function that we have factored out, and I have that the product x minus 5 times the product of x plus 1 equals 0. So that means that either x minus 5 equals 0 or that x plus 1 equals 0. Does that make sense? Because this is no different than m times n equals 0. So then either m equals 0, which is what we just learned, or n equals 0. Okay? That's what you just learned. So if I wanted you to solve for x given those two expressions, how would you do that? Well, I would add 5 on this one. So that means that x equals a positive 5, or x equals a negative 1. So I just want to draw your mind back to this thing that we boiled out to find. It's saying that if you let x equal 5, if x equals 5, let's see, 5 squared minus 4 times 5 minus 5, then you'll get a 0. Well, let's try that. I don't believe it. 5 squared is 25 minus 4 times 5 is 20. So 25 minus 20 is 5 minus 5 more is, okay, so it works for the 5. Let's see if it works for the negative 1. Negative 1 squared minus 4 times negative 1 minus 5. Well, this is 1 plus 4 minus 5. It works. So these two x equals are called solutions. These are the solutions to the quadratic. And we're going to keep doing this for the next 2 days, 3 days probably. Okay. So let's look at our next example. So what is this telling me? That we took a what out? Yeah, it had a GCF of 5. So this product says that 5 equals 0, or x plus 3 equals 0, or x plus 4 equals 0. So is 5 equal to 0? No, that's why we take it out. So you just kind of ignore that number on the outside. Does that make sense? You just ignore it. So if I have x plus 3 equals 0, what does x really equal? If x plus 3 equals 0, what is x? -3. I would have to subtract 3 from both sides. And if x plus 4 equals 0, what is x? -4. We're just subtracting 4 from both sides. So this one is different because it has a variable term on it. So this says that either 2x equals 0, or that x, I don't know why I put a parenthesis there, sorry, or that x plus 6 equals 0. So let's write that out. Well, if 2 times x equals 0, divide both sides by 2, that means that x has to be 0. That's what Tessa said. Any number times 0 is going to give you 0. If x plus 6 equals 0, that means that x has to equal -6. Again, these are called solutions to the quadratic. Solutions. Okay. So in the first one, let's look at this really fast. It says in B, why is it okay to divide by 5? So if I wanted to get rid of this 5 and I divided both sides by 5, what is 0 divided by 5? Because that would make the 5 go away at the front, but what is 0 divided by 5? 0. That's why I just cancel it out. So this is saying, this is kind of explaining to you what I did here. Does that make sense? So 0 divided by 5 is still 0. That's why it's okay to just cancel them out. Okay. In C, why can we not divide both sides by x? Why can we not divide both sides by, like if I wanted to get that term out front away, why can I not divide both sides by 2x? Well, let's look at that and see what happens. If I were to divide this whole side by 2x and this by 2x, it goes away there, but why can I not divide by x? Well, are you allowed to divide by 0? Can you ever divide by 0? No, it's mathematically gross. It's undefined. It's not allowed. And we don't know what x is, right? Do we know what the value of x is? No, that's why you can't divide by x. So x could be 0, and we cannot divide by 0 ever. So we're going to do this again. And we're going to take this factored quadratic, and we are going to figure out which ones are the solutions. So let's see, I have 2 times the quantity x minus 4 times the quantity x plus 7, and that has to equal 0. Okay, so if I divide everything by 2, that's how I get rid of my 2. I just want to show you how that happens. That just, these cancel out, right? And 0 divided by 0, or 0 divided by 2 is still 0. So I have x minus 4 times x plus 7 equals 0. So you do not have to show this step, because you guys should just know that they just cross off. If there's no variable, they just cancel out, okay? I'm trying to save you a step there. So if x minus 4 times x plus 7 equals 0, then x minus 4 equals 0, or x plus 7 equals 0. So add 4 to both sides, and that means that x equals 4, or subtract 7 from both sides, x equals -7. Does the 2 have any bearing in our solution? Does the 2 do anything for us? It does not. So which one of the following is the solution to this equation? Well, it's the positive 4, negative 7. Number 2. So it says, hey, clearly this process is easy enough if the quadratic, if the polynomial is already in factored form, but if it's not, then we have to factor it, okay? So that's where we're going to next. So this is what you have been dealing with. We're not going to do it on a calculator today. Today we're just going to use our brains. So we took a trinomial, a polynomial, something that we've been working with, and we set it equal to 0. And we're trying to find where it crosses the x-axis. Replace the y with a 0. This is no different than what you did when you started learning about linear function. You started off with x plus 2 or 2x plus 2, and then you added a y to it and you started graphing them. It's the exact same thing. So we have to factor that. We have to factor that polynomial, that quadratic, x squared plus 7x plus 10. So we're still going to follow the same methods, times plus chart. Let's factor this. So if I use a times plus chart here, and I factor this, times plus, I get 10 and 7. What two numbers, whoops, sorry, that's up too high. What two numbers can I multiply together to get 10 that when I add Lanaya, I get 7? Okay, someone tell me about the leading coefficient. What is the value of the leading coefficient? It's 1. Sorry, I had to take a drink. And when the leading coefficient is 1, the factors that you choose are the factors that you use. So this factors out to x plus 5 times x plus 2 equals 0. So the only thing that we're doing differently, those are kind of smushed together. The only thing that we're doing differently is I'm just taking your quadratics that you've been working with, and I'm just saying that it equals 0 to try and lend your brain to this idea, okay? So the zero product property says that either x plus 5 equals 0 or that x plus 2 equals 0. So let's figure out what x is. So for the first one, I'm going to subtract 5 from both sides. So that means that x equals negative 5. And for the second one, I'm going to subtract 2 from both sides, and that means that x is negative 2. Y'all are going to get to the point that if you see x plus something, you know that the solution is the opposite. And if you see x minus something, you know that the solution is the opposite. You're going to do this so much that you're going to be able to look at the binomial and already know what your solutions are. But right now we'll play this game. So what is this? What kind of quadratic is this? It's a dots. It's a difference of two squares. And I know this factors out to x squared is made by x times x. And the square root of 25 is 5. And remember we join with a plus and a minus. We're going to say it equals 0. So this is just factoring, and I set it equal to 0. So that means that x plus 5 equals 0, or that x minus 5 equals 0. So if x plus 5 equals 0, what does x equal? Negative 5. And if x minus 5 equals 0, what does x equal? Positive 5. I determined that by subtracting 5 from both sides. This is just a one-step equation, right? Okay, everybody should be writing this down. Sitting here and absorbing the message is really not acceptable. It's not a sermon. We're not in church. Okay, what about this next one? This one's a little different. What can I do? What is the GCF, McKinley? So I'm going to divide everything by 3x. So I take out my 3x, and I'm left with x minus 5, and they equal 0. So what actually equals 0, McKinley? So 3x equals 0, because remember, if it's got a variable on it, you have to use it, and x minus 5 equals 0. So if 3x equals 0, divide both sides by 3, that means that x is 0. If x minus 5 equals 0, add 5 to both sides. That means that x equals positive 5. Okay. Do you want to check it? Do you guys believe it? Yeah? No, does anyone want to check it, want to see it work? Nobody wants to see it? I'm that type of person that like, I don't believe it. I have to see it. Everybody here is just going to take my word for it. Nobody wants proof today. Okay. All right. Okay. It is an advantage, but it is not essential to factor completely when you solve quadratics. So we're going to find the values of x. Well, we're going to factor completely. I don't care what this says. So here we go. What can we take out here? That first one, example A, what does it have? A GCF of 5. Okay, if I take out a 5, I'm left with x squared minus 3x minus 40. Okay, so let's see. Times plus chart. I'm multiplying together to equal a negative 40, and when I add them, I get a negative 3. Tell me that those just jump off the page for you. Or they don't. I don't know. Let's see. 2 and 20, that's not going to work. 4 and 10, that's not going to work. How about 5 and 8? Yeah, which one do you want to be negative? Yes, the 8 must be negative. What's the value of my leading coefficient? That means that the factors that you choose are the factors that you use. So this is really going to factor out to x plus 5 times x minus 8 equals 0. Putting my 5 out front. Divide both sides by 5. If there's no variable attached here, you can just get rid of it, right? Because 0 divided by 5 is just 0. Just ignore it. If there's a variable attached, it's important. But if there's no variable, it's just a constant, it just goes away. So I either have x plus 5 equals 0 or x minus 8 equals 0. Well, if x plus 5 equals 0, that means x equals, subtract 5 from both sides. Yes, negative 5. If x minus 8 equals 0, add 8 to both sides. That means x equals, these are my solutions. These are my solutions. Okay, example B. What can we take out of there? A 2. Go away. So if I take a 2 out, I'm left with x squared minus 7x plus 10 times plus chart, multiply to get a positive 10, adds to a negative 7. What are those numbers going to be? Negative 2, negative 5. Who said that? Good job. Good job. Okay, so leading coefficient is 1. So I have x minus 2 times x minus 5. This all equals 0. That means that x equals 2 or that x equals 5. Does anyone need me to explain that? Does anyone need me to set that one up for them? Are y'all awake today? No? Okay. All right. So we have 4 examples. Let's divvy it up. Who wants to do example number 1? Don't everybody jump at once. Okay. Alexis, pick 4 people to be on your team. I don't care who they are. Just choose them and go over by Alexis. You guys are going to factor this together as a team on the board. So Alexis, you guys are erase number 11 up there. You guys are going to factor it up there. Pick 4 people. Choose them. Just point at them if you don't know their names. Point them. 1, 2, 3, 4. You 4. Go up there with Alexis. Erase the board, factor it out, grab a marker. Okay. Alexis and team. Number 2. Who wants to do number 2? McKinley. McKinley, I want you to pick 4 other people to be with you. And you are going to go on the other side of the lighted board. Okay. Ready, go. Just pick 4 people. Shh. Yeah. 5. So there should be 5 each. You plus 4. So pick, once you grab Naomi and Tessa or Lanaya. Okay. Macy. Pick 4 people, Macy. Okay. Macy, you guys are going to be on this side of the board. Cross your section. Right here. Number 4. Doing number 4. Team Miles and Evan volunteered, so I won't use Miles as a guinea pig. Evan, pick 4 people, take them up there. So there should be 5 of you. You guys are going to be right here. Violet, it's okay. Pick 4. Go. If you're not on a team, pick one and try to solve it with the people sitting around you. Pick one and try to solve it with the people sitting around you. You guys are sleepy.
Come on, Gordon.
Whoa. You're solving. Listen to me. You guys over there, 2x minus 3 equals 0. So you're dividing both sides by 2, just like that. That's your answer. You're right on the money. Leave it alone. You can have a fraction. So McKinley, I want you to write what your x is equal up there on the board. Underneath number 2. What about the other one? What about that guy out front? Good job. Okay. Write it on the board. Nice job, number 3. That's correct. Yes. Awesome. Nice job, team 1. Perfect. Awesome. Perfect. Write them on the board. Excellent. Someone write them on the board. Evan, you're up. One of you, Evan, since you're up there, Evan E, write your solutions on the board. Evan Easton. Yeah, up front, right there under number 4. Just write down your 2 x equals. X equals what? X equals what? Okay, we're not done yet. I'm going to ask you to do, you're perfect. I'm going to ask you to do 2 things. For this first one, we're going to look at this one together. X equals 7 and x equals 5. If I were to ask you to tell me what two binomials did that come from? How would you do that? Meaning, what were the 2 factors that were used to get this? Remember, to get this, all we did was set this equal to 0. So if I subtract 7 from both sides, I have x minus 7 equals 0. So I started with this, right? And if I subtracted 5 from both sides, I have x minus 5 equals 0. So the 2 factors were x minus 7 and x minus 5. Does that make sense? Just want you to know how to determine what the binomial factors were from looking at a solution. The other thing I want you to do is pick one of these anywhere at your desk, pick one of them and check it. Plug it back in and make sure that it really does equal 0. I'm going to do number 1 with you so you understand what I'm saying. So if x truly equals 7, 7 squared minus 12 times 7. So you can't do number 1. That's what I'm saying. Plus 35 equals 0. Let's see. 7 squared is 49 minus 84 plus 35 equals 0. 49 minus 84 is negative 35 plus 35 equals 0. So that works. Now I have to try the 5. I'm just taking this, replacing the x's. I'm plugging it back in. So 5 squared minus 12 times 5 plus 35 equals 0. 25 minus 60. 25 minus 60 plus 35 equals 0. Negative 35 plus 35 equals 0. So it works. Check one of them. Check either number 2, check number 3, check number 4. I don't care which one you check, but I want you to tell me if it works. Just show a check on one of them, because you might have to check your solution one time, and I want you to know how to do it. I want you to know how to do it. Number 3 works. So you did 6 squared minus 36 equals 0, and that's true. And then you did negative 6 squared minus 36, and negative 6 times negative 6 is a positive 36, and that also equals 0. Yep, that was a good one to do. Smart. Do you guys understand what I'm asking you to do? You're just plugging it back in to check, okay? So your homework is pretty easy. It's pages 3 and 4. Pages 3 and 4. There's only 15 questions, and 1, 2, 3, 4, 5 of them are multiple choice. So you have 15 questions, 5 are multiple choice. But I need to do some rattling. I have to tell you guys some things. So